Show that f of x equals 11 tan to the minus 1 of 2x minus 3x squared has a stationary value when x satisfies this equation here. You may assume that the equation here has a root alpha between 0 and 1. The recurrence relation given here with x0 equals 0.9 can be used to find alpha. Find and record the values of x1 to x4. Write down the value of x4 correct to 5 decimal places and show that this is the value of alpha correct to 5 decimal places. So let's have a little look at this then. Here's the question here in summary form. So stationary point first of all, then for part A. So let's differentiate then. So f dash x dy dx, or f dash x, is equal to tan arc tan 1 over 1 plus x squared, isn't it? So it's 11 lots of. Tan of something goes to 1 over 1 plus the something squared, multiplied by the something differentiated, which is 2, minus, and then differentiate this, 2 comes down to we with the 3 to make 6, x, and let that equal 0. So this tells us now then that cancel by 2 all the way through on both terms here and here, so 11 over 1 plus 4x squared, when we expand this bracket, is equal to, and move the 6x, which is now 3x, because we cancelled by 2, both sides, so we get that. So that tells us then that 11 is equal to 3x, 1 plus 4x squared, and so when we expand this bracket we'll get 12x cubed plus 3x, and then move the 11 over to be with it minus 11, and there's nothing left on the other side, and I've written it down from right to left. So there's the cubic equation that we needed to show. So assuming this has a root alpha between 0 and 1, here's the recurrence relation then, which we need to type in the calculator to find alpha. x0 is 0.9, so let's put that in straight away, 0.9. Put it in as answer by pressing equals. Now if we do this then, this calculation, I'll move this out of the way here. So, answer, oh, I cleared it, didn't I? So 0.9 equals, so now I've got that in the thing. So let's do 11 minus 3 times answer over 12. So bracket 11 minus 3 times answer, which is the 0.9, close that bracket, divided by 12, close that whole bracket, and that's power, and we want power third, don't we? So if we press equals on that, we'll get the answer for x1. So let's put that down. So here, I'll put it down here, x1 is equal to 0.884366, 884366 dot x2 is equal to, so just press equals again now because it will recalculate the answer in here, 886029. x3 next, so press equals again, 885853, 852, 885, 852. And then press it once more to get x4. So here's x4 then. Let's just give ourselves a little bit more room. 885871, 885871, x4, 885871, and the 1 was the decimal place that when we round it, it still remains a 1 when we looked at that number. Even to 60p here it would be a 1, wouldn't it? So no problem there. So write down x4 to 5dp, so x4 is equal to this number then, 88587, and that's to 5 decimal places, of course. And show that this is the value of alpha to 5dp. So what we need to do then, we'll get back to the f of x, the root 12x cubed plus 3x minus 11. Fx is equal to 12x cubed plus 3x minus 11. So if we try f of, to prove this is the root alpha to 5dp, let's look at either side of this value to see if this changes sign. So let's look at 0.885875. So if we look at that, okay, so we'll look at that then. So tap that in the calculator. So we'll move this over the other side. So we've got 12 times this cube. So I'm going to put this as an answer. No, I'll just write 12 times x cubed, 0.885875 bracket cubed, plus 3 times bracket 0.885875 bracket minus 11 equals. Just go back and correct it then. Minus 12 times, we don't need that bracket there. So equals. So we've got a positive small value. So let's try f of 0.88588786 5. Let's try that then and see if that's negative now. So let's go back. We need to change it twice, don't we? We need to change a 7 to a 6. A 6 there. And change that 7 to a 6. And equals negative small, yeah? Negative small. So we can see that the sign of the root here and here for these two values, it crosses, the root lies between these two, so the 5dp is going to be 0.88587.